Let's talk about an integration technique involving something called partial fraction decomposition. Now, partial fraction decomposition is basically another version of change the way it looks. And before we begin, I want to remind you of what a rational number is. A rational number is basically a fraction. So it's like P over Q, where each of these guys are integers. This is an integer, and this number is also an integer. For example, if you had something like 7 divided by 5, that would be a rational number. We talk about rational numbers because we really want to define what a rational function is. And a rational function is a function of the form p of x divided by q of x, where each of these objects on the numerator and the denominator are polynomials. Okay? So for example, I could have something like f of x is equal to 7x to the 21st power plus 8x minus 16 divided by 8x to the 24 plus 11. As you can see, the numerator is a polynomial, the denominator is a polynomial. So f of x would be a rational function. Okay. Now, in general, we're going to call the numerator p of x, and we're going to call the denominator q of x. So the degree of the numerator, we're going to give that the letter n, and the degree of the denominator is going to be m. So going back to our example, p of x is equal to 7 times x to the 21st power plus 8x plus 16, and n in this case is going to equal to 21. For the denominator, q of x is equal to 8x to the 24th power plus 11, and our m is going to be equal to 24 in that ludicrous example. Okay. Now, before we talk about partial fraction decomposition, I wanted to remind you that, when trying to integrate a rational function, you should first look for the simplest solution. So you should first try u substitution. Sometimes everything works out nice and you don't have to go through the arduous partial fraction decomposition process. Let's assume that we cannot use u substitution. In other words, u substitution does not work. Then what we're going to do is we're going to learn a new technique called partial fraction decomposition. And what that entails is, it's an integration technique that we use for rational functions. That's why we defined it at the beginning. Where we really change the way the integral looks. Okay. So how do we change the way the integral looks? Well, that's what we want to explain next. So I want to take you back to the days of adding two fractions. And whenever you add two fractions, in general, the first thing you want to do is you want to find a common denominator. All right. So let's take a look at it at an example. So let's say you want to add 1/2 plus 1/3. They have different denominators of 2 and 3. And because these guys have no common factors, we could say that the common denominator is going to be 6. So how do I add these fractions? Well, first I rewrite 1/2 with a denominator of 6. So that's going to give me a 3 over 6. And then I rewrite 1/3 with the denominator of 6. So that's going to be plus 2 over 6, right? And then when we added these guys together, you would end up with 5 over 6. So to repeat, what we did was we started off with two fractions with different denominators. Then what we did was we We found a common denominator. And then once we had the common denominator, we added the numerators together to get a single fraction. So when adding two fractions, it's almost like we're moving from left to right in this description that I've just described. Now, in the case of a partial fraction decomposition, we actually want to go in the opposite direction. So we want to start with our single fraction of, let's say, 5/6, and we want to be able to break it up into the sum of two fractions. So this is the partial fraction decomposition. In other words, you're taking a fraction and you're breaking it up into smaller pieces. So when we worked with 5/6, that 5/6 will be decomposed into 1/2 plus 1/3. And the idea, once we switch to rational functions instead of rational numbers, is that the left-hand side, this might be some very complicated thing to integrate, but when we decompose it, the idea is that these pieces over here might be easier to integrate. So in order to really accomplish this, actually, before we even get started with partial fraction decomposition, we really need to review how to divide polynomials. So I guess the first thing to know is, when do we need to divide our polynomials? Well, let's take a look at this situation over here. When I look at the degree of the numerator n is equal to 1, and the degree of the denominator m is equal to 2. So when I go ahead and I try to divide these polynomials over here, the numerator goes sort of inside this little house. So this is like an x minus 3. And the divisor, the bottom, goes to the right of that little house thing. This is 2x squared minus 5x minus 1. So the degree inside here is equal to 1. The degree that we're trying to divide by, or the degree of the polynomial we're trying to divide by, is degree 2. 2 is bigger than 1. So we cannot divide. Okay? So we're not really going to worry about this case where the degree of the numerator is less than the degree of the denominator. Let's take a look at example 2, though. In example 2, we have that the degree of the numerator is n is going to equal to 6, and the degree of the denominator m is equal to 3. So since 6 is greater than 3, we need to divide. So I'm going to draw my little house thing over here. And the numerator goes inside the house. I want you to notice that when I look at this polynomial here, there are certain terms that are missing. The x to the 5th term is missing, the x cubed, the x squared term, these are all missing. So when I go and I write my polynomial on the inside, I need to fill in those missing terms. So I have x to the 6th plus 0 times x to the 5th plus 2 times x to the 4th plus 0 times x cubed plus 0 times x squared plus 6x plus 9. So I mean, this example is a little bit ridiculous because I wanted to prove a point. The point is, you got to fill in these missing terms with 0 coefficients. For the denominator piece, we're missing a couple terms, so I need to make sure I write those in. So we'll have x cubed plus 0x squared plus 0x plus 3. All right. Now, I want to cancel out this x to the 6th term. So what do I need to multiply x cubed by to achieve x to the 6th? Well, I need a x cubed. Now I'm going to multiply the polynomial on the outside by the x cubed. I'm going to get x to the 6th plus 0x to the 5th plus 0x to the 4th plus 3x cubed. Okay, and I want to subtract this polynomial from this polynomial. So to make sure I do that, I'm going to put parentheses here. I'm going to put a subtraction sign, and then let's subtract term by term. So x to the 6 minus x to the 6 is 0. 0x to the 5th minus 0x to the 5th is 0. So the first non-zero term I get is going to be 2x to the 4th. Then when I subtract away the 3x cubed, I get minus 3x cubed. And then the rest of this comes down, so this will be plus 0x squared plus 6x plus 9. Okay. Now I want to divide this polynomial here by this guy. So I really want to cancel out the leading term, the 2x to the 4th. So I hope you all can see that I want to multiply the x cubed by 2x, and then that'll cancel out this leading term. So I'm going to put a 2x on top over here, and then I'm going to multiply this entire polynomial by 2x, and we are going to get 2x to the 4th plus 0x cubed plus 0x squared plus 6x. Okay, I want to subtract those two polynomials, so I'm going to put parentheses around the second one and the negative so that I don't forget to subtract term by term. And what am I going to get now? So the leading terms cancel out. I'm going to get negative 3x cubed. I'm going to get plus 0x squared plus 0x plus 9. All right. Now, I still have to go one more step. I have to go one more step because when I look at the degree of my remainder, that's the same as the degree of my divisor. So I really need to divide one more time. So how am I going to cancel out this leading term? I need to multiply the leading term of our divisor by negative 3. So I'm going to put a negative 3 up top here. I'm going to multiply and distribute. I'm going to get negative 3x cubed plus 0x squared plus 0x minus 9. So when I subtract these two polynomials, I'm going to end up with just a remainder of 18. Okay. So let's look at our results. So we have a remainder of 18. We have a polynomial quotient. So really, I could write my final answer as follows. Maybe I'll write it in a different color. I'll write it in black over here. Okay. So my x to the 6th plus 2x to the 4th plus 6x minus 9, all divided by x cubed plus 3, that guy is going to be equal to x cubed plus 2x minus 3, and then this is how I write the remainder. I put plus 18 divided by what my divisor was, x cubed plus 3. So the original rational function is exactly equal to this polynomial plus a rational function that looks much simpler than the original one. Okay, so this is our brief introduction into partial fraction decomposition. Before we even really get started with the decomposition, we really need to talk about polynomial division first. All right, everyone, take care.